Now this one is intimidating. Now we have been provided that tan A is equal to n tan B and sin A is equal to m sin B, and we need to prove cos square A is equal to m square minus 1 divided by n square minus 1. Now apparently there is no direct relation between tan A and sin A, but if we observe carefully we see that reciprocal of tan A, that is cot A, and reciprocal of sin A, that is cosec A, these two does have a relation, that is cot square A plus 1 will give you cosec square A. So this is the relation that we can utilize to solve this. So let us try to do it. First we have been given tan A is equal to n tan B. So that implies 1 by cot A is equal to n divided by cot B. Therefore, cot B is equal to n cot A. Let us call this as equation 1. Similarly, sin A is equal to m sin B. I can write it as 1 by cosec A is equal to m by cosec B. So that will lead me to cosec B is equal to m cosec A. So this is number 2. Now if you observe, we have cos square A is equal to this expression. So let us write everything in terms of cos, in terms of B. So we have to do away with variable B. So I can write cosec square B is equal to 1 plus cot square B. And instead of writing cosec square B, I am going to write here m square cosec square A. I'm going to write 1 plus, now instead of writing cot square B, I'm going to write n square cot square A. So from here, we can write this is equal to, let me write m square divided by, instead of writing cosec square A, let me write it as sin square A is equal to 1 plus n square. I can write, instead of writing cot square A, I can write it as cos square A divided by sin square A. Now let me multiply both sides by sin square A. So that will give me m square plus sin square multiplied by 1. Sorry, this will be equal to, is equal to, I'll be having sin square A plus, now sin, this expression multiplied by sin square A will cancel out sin square A and we'll be left with n square A cos square A. Okay, so let this be m square. Now instead of writing sin square A, I can write 1 minus cos square A, because we know sin square A plus cos square A is equal to 1. That will give us sin square A equal to 1 minus cos square A. So plus n square cos square A. So now let me do one thing. Let me write this m square. Let me take this minus 1 on the left hand side. So m square minus 1, and I'll be let me do this cos square A. Let me take this as common, cos square A. So I'll be left with n square minus 1. So now cos square A is equal to m square minus 1. Let me bring this down to n square minus 1. So it gives cos square A is equal to m square minus 1 divided by n square minus 1. Is it not the same thing that we have been asked to prove? Yes, cos square is equal to m square minus 1 divided by n square minus 1. Nice.